In this chapter, I'm going to show you how to clone mushroom tissue. The procedure is extremely simple. We'll be tearing open a fruit body, cut a very small section of mycelium out, and transfer it to agar. Let's watch. The first example we're going to clone today is a shiitake mushroom. We have a beautiful specimen here that I want to keep the genetics alive on, so we're going to clone it. But as with anything we do in sterile work, the very first step is to flame sterilize our scalpel. You'll notice I tear open the fruit body rather than cutting it. If we were to cut it, there's always a chance that our scalpel is going to push contaminants from the outer edge into the center. Then you'll notice we just kind of drag the scalpel across the tissue a little bit until we get a tiny piece no larger than a grain of rice, and we put that on our agar. Then of course we flame sterilize before the next transfer. Let's bring our camera in a little bit closer and we'll take one more transfer from this shiitake cap. You'll see here, dragging it really does work to get a piece of tissue on your scalpel. It's a lot easier than trying to dig in and cut a wedge out. This next picture is the second transfer after cloning. I like to put the tissue on agar, and within about 48 hours you'll see the mycelium starting to grow out from your sample. At that point, cut a little bit of mycelium from the leading edge and transfer that to a second petri dish. And then the second petri dish can be used to inoculate either grains or a test tube master for long-term storage. Let me again say that I cannot emphasize enough the importance of flame sterilizing your scalpel between transfers, as well as washing your gloves with alcohol between each and every transfer. Obviously, you want to wash your gloves after you flame sterilize. Don't get your gloves wet with alcohol and then go towards your torch. But doing the above absolutely eliminates the possibility of cross-contamination between your cultures. We'll do this one more time with a different species. This time it's Hypsocygus oemarius, sometimes referred to as the elm oyster. And as you can see, we'll tear the stem open as we did with the shiitake, and we'll drag our scalpel across it in order to take our sample. And we'll go ahead and get one more. Now, even though I'm only showing you a couple of transfers from each of these species, bear in mind when I clone tissue, especially wild mushrooms, I'll clone anywhere from 15 to 20 petri dishes worth of product, because that way I can afford to lose half or even 2/3 of them to contamination, but the 1 or 2 petri dishes that work are going to save that species and keep it in my collection forever. Here's one more method of cloning I'd like to show you. If you grow from multispore inoculation, a lot of times you don't know what you're going to get until you get it. But if you have a beautiful flush, or the mushrooms have other qualities that you want to preserve, you can actually take some small pins like this. Mushroom pins are generally doubling in size every 24 hours, so the mycelium is growing very rapidly. You can actually cut these pins and drop them on agar, and even if there's contaminants on the outside edge of the mushroom, the mycelium will grow so fast it will outrun them. This next picture is about 4 or 5 days later, and you can see the mycelium has really taken off and grown. So at this point, you can go along the outer edge, on the leading edge of the mycelium, take a tiny little bit, no larger than a grain of rice, and move that to a second petri dish to grow out, and you'll be able to preserve that strain. Next, I'd like to talk about some common problems that you're going to see with cloning. This picture is a beautiful cluster of oyster mushrooms that Vivian and I found a couple of summers ago up in the mountains, and as soon as I saw it growing on an alder tree, I knew right away I wanted to clone it. But when you clone mushrooms, especially when you clone mushrooms from the wild, you're bringing in all sorts of fungal contaminants and bacteria right along with it, so you have to be able to isolate away from those contaminants. The next two Petri dishes I'm going to show you were both started directly from this cluster. If you look up here in the upper right-hand side, I put a highlight on it, you'll see bacteria. And we really, as mycologists, don't need to worry trying to identify exactly what type of bacteria it is. If you see this white, greasy, milky-looking growth, then you know it's bad. So that section of our Petri dish is no good. As we pan over here to the left, everything we see is white, but if you look between about 4 and 6 o'clock, you'll see 3 satellite colonies, and I'll highlight each one of them separately so you can see what they are. These are molds that have started growing, and while they haven't changed color yet, trust me, within a week they will. So that section is no good. Moving down here to the bottom section, it actually looks pretty good. So if this was the only dish we had, I could carefully in a glove box open it up, and I highlighted a section here on the leading edge of the mycelium. We could transfer really from anywhere around the perimeter of that growth. But fortunately, I did about 20 Petri dishes that day, so I had some with no contamination, and I was able to just leave that dish sealed up. Moving back to that oyster cluster we saw before, here's another Petri dish that was inoculated with tissue cloned from that cluster. This is the one I used to perpetuate my strain. Down in the bottom, that section is okay. That large piece you see, when I went to scrape a piece of tissue with my scalpel, a rather large chunk came out. So I just went ahead, since it was separated, and plopped it down. That piece ended up growing out rather contaminant-free. As we move up to the upper right, I do see one satellite colony at about the 5 o'clock position, so I didn't use that one. And then as we move over to the left to the other section, it looks fine too. So I ended up taking mycelium from this dish and transferred it again to another dish, which we will look at next. And here you see the next transfer. This is the second transfer from the clone. It's actually the next transfer away from the dish you just saw, and we have 3 pure monocultures now. These were then used to inoculate my grain masters, and 2 or 3 pieces from around the leading edge of one of these were used to inoculate my master culture slant so I can preserve this strain. It often takes a lot more than 2 transfers away from an outdoor mushroom to get to this point, but I padded my bed a little bit, and when I brought that mushroom cluster home, I filled up about 20 Petri dishes with clones from that, and each of these Petri dishes has 3 sections, so I ended up taking about 60 clones, and I was able that way to cherry pick the best of the best, and in only 2 transfers I was able to get to this point. If you try to be cheap with your Petri dishes and only make 1 or 2 clones, you're going to end up having to do a lot more transfers in order to get a pure culture, and then your mycelium is going to grow out a lot more on agar, and of course as it grows out you have other problems such as senescence. So taking the maximum number of clones that you can afford the Petri dishes to do is always a good idea, because this gives me a very low what we call p-value by having mycelium that hasn't grown out very much to get to this point. And here you see Vivian holding a bowl of mushrooms from our very first harvest after cloning this oyster cluster. And of course we've had many more harvests since that time. Well, now that you've had a chance to see what it looks like when things go as we plan them, this chapter wouldn't be complete without letting you see what it's like the way we don't plan it. This is Trichoderma, the forest green mold, and this was also inoculated with tissue from that mushroom cluster that you saw earlier. And I see no redeeming qualities whatsoever on this Petri dish. Sometimes you'll have a little bit of mushroom mycelium trying to ease out from around the mold, and in a case like that, you can actually put the dish into a glove box, or better yet, a clear plastic trash bag, and you can reach in and transfer your mushroom mycelium to a new Petri dish. And often doing that, you can make 2 or 3 transfers a couple of days apart, and you can end up with a pure culture, even though your original sample was contaminated. I show this Petri dish because I want to make the point very clear. If you have a laminar flow hood, whatever you do, never open a Petri dish like this one in front of your flow hood, because the breeze from your hood will blow the spores everywhere. They'll get all over you, they'll get all over your house, the walls. Your future crops will be destroyed. So if you do need to transfer away from contaminants, use a plastic trash bag or a glove box, but never a flow hood. Well, let's recap what we've just gone over. First and foremost, always use a glove box or a laminar flow hood when you're cloning. During this video, we did not clone an outdoor mushroom. The 2 samples that you saw me clone here were both indoor grown, so I was able to use my laminar flow hood. It made it a lot easier to film. Whenever I bring outdoor mushrooms, or we've brought in something like the cluster you saw of those oyster mushrooms from the wild, I never clone those in front of the flow hood because they've always got a lot of contaminants all over them, and the flow hood is just going to blow that right into the room. And if you're like me and you're growing at home, your sterile laboratory happens to be your bedroom, which is also your grow room, and anything your flow hood blows into the air is going to contaminate your other projects. Always wear surgical gloves, a mask, a hairnet. When this video started, you saw me, I already had all of that on. So rather than use up 10 minutes of time in this section with you watching me put the gloves on, I already had that done. But you need to put on the gloves. I use Tyvek wrist sleeves, and once I get the latex gloves on, I always pour alcohol in my hands and wash the gloves very well. I cannot emphasize enough how important it is to flame sterilize your scalpel red hot before starting work, and again in between each and every transfer. If you transfer one piece of contaminated tissue and then you don't sterilize your scalpel, you're going to contaminate every single thing you transfer after that point. So play it safe. Even when you're transferring indoor grown mushrooms that you think are clean, even when you're transferring from one beautiful Petri dish to another, flame sterilize between every single transfer. When you bring wild mushrooms home, always wash them down with iodine prior to putting them in your sterile work area. This is going to knock the bacteria back, and without really shocking the mushroom mycelium. What I'm finding a lot with people in the online forums is when they do cloning, they often will dip their tissue into hydrogen peroxide. And I just don't recommend that at all, because the peroxide is also damaging to your mushroom mycelium. So now you're making a transfer to agar, but your transfer has just been shocked, and it's going to have to recover from the hydrogen peroxide, and you don't give it a head start. If you use iodine, then put your tissue into your agar, the bacteria will be knocked back, but not your mushroom mycelium. And then as soon as it starts to grow, you can begin making your transfers. And I mean, the very day you see mycelium growing, reach in with your scalpel and get it. And very often you'll be transferring mold when you do this, but that's okay. Transfer every single growth you see and transfer that into a new Petri dish. Within a week or so, the mold will change colors and you can just throw those dishes out. But by doing it that way, you get the healthy mycelium and you transfer that away from the contaminants. And again, always transfer the healthy mycelium away. Don't try to reach into a contaminated dish and cut the contamination out, because doing so is going to release billions of contaminant spores, and they're just going to land right on top of your mushroom mycelium, and you're not going to gain anything. So if you do have a contaminated Petri dish and you have some healthy mycelium along with it, number one, never open it in front of your flow hood, because that's just going to send those contaminant spores airborne. So get out a clear plastic trash bag and put your work in there, or use a glove box. I prefer the plastic trash bags because as soon as I make the transfers, I can throw the bag away. If you use a glove box, you just have to clean it up. But the important thing to remember is always transfer the healthy mycelium and leave the contaminants alone. And I can't emphasize this enough either. Never open a contaminated Petri dish or jar or anything else in front of a laminar flow hood. That is a big mistake. So happy cloning.